Hello everyone, in this video I will work examples for section 9.7 in which we're studying marginal analysis. So in the first example, we're asked to evaluate the polynomial function at the given values of the variable. So in this case, the variable is w, and we're asked to evaluate p at 7. So in our case, w equals 7. So we're going to plug in 7 for w. So here we go. 7 times, instead of w, we plug in 7 squared minus 2 times w, which is 7, then plus 9. This equals to 7 times 49 minus 14 plus 9. Let's do this on the computer. Use a calculator. So that's 338. P of 0 equals 7 times 0 squared minus 2 times 0 plus 9. 7 times 0 squared is 0, minus 2 times 0 is 0, plus 9 plus 9. Okay. Next example. We're asked to evaluate the polynomial, which again is of the second degree polynomial when x equals 6. So in our case, the variable is x. So p of 6 equals, we're going to input 6 instead of x. So I'm going to have 6 squared plus 6 plus 2. 6 times 6 is 36, plus 6 plus 2, 42 plus 2, 44. Okay. The next example asks us to find the marginal cost function. Recall that the marginal cost function is actually the first derivative, c prime of x. And c prime of x, in our case, since c of x is 177 plus 0.7x, and the derivative of the sum of these two terms is going to be the sum of the derivatives. Recall the derivative of a constant is 0. So the derivative of 177 is 0, plus the derivative of 0.7 times x is 0.7, so 0.7. The marginal cost, which is a function of x, is 0.7. So notice here that our cost function is a linear function and the derivative of a linear function is the slope. Here we have another example. We're asked to find the marginal cost, and the marginal cost is the first derivative. So here again, we have a polynomial function of degree 2. Let's recall the power rule of finding the derivative. We're going to have x to the n, where x is a variable and the base of this power, and n is a fixed exponent. Let me make this better. That's a sorry n. To the n. The derivative is found by bringing the exponent down times the power with base x and reduce the exponent by 1 and minus 1. So if I have x to the fourth and I want to find the derivative of x to the fourth, it's going to be 4 times x to the 4 minus 1, which is 4 times x to the third. So now that we know the power rule, and also we know that when we sum up terms, the derivative of the sum is the sum of derivative. So without further ado, let's find c prime of x, which is the derivative of the first term, and the first term is constant. Derivative of constant is 0, plus the derivative of the second term, which is 2.9 times x. So that is 2.9 times x to the 1 minus 1 minus 0.07 times, we have x squared, so we're going to use the power rule for x squared. So we're going to bring 2 down times x to the 2 minus 1. So let's simplify this. 0 plus 2.9 times x to the 1 minus 1 is x to the 0 minus 2 times 0.07 is 0.14 times x to the first. X to the 0 is 1. Let's remember that also. So the answer is 2.9 minus 0.14 times x. Okay, find the marginal revenue. So again, find the derivative here by using the power rule. So r prime of x equals the derivative of the first term is 5 times x to the 1 minus 1. Notice that x is the same as x to the first, so the exponent of it is 1. So I use the power rule. Minus 0.08 times 2 times x to the 2 minus 1, power rule. Let's simplify this. 5 times x to the 0 minus 0.08 times 2 is 0.16 times x to the first, and x to the 0 is 1, so we get 5 times x to the 0, we get 5 minus 0.16 times x. Find the average cost function if cost and revenue are given by C of x equals 146 plus 4.4x and R of x is 9x minus 0.08 times x squared. Okay, notice here that we're given the revenue function, but we're not asked to do anything about it. All we're asked to do is find the average cost function. So when we're given the total cost, which in our case, we're given total cost C of x, the average cost, which we're going to denote as C bar of x, that equals the total cost, which is C of x divided by X, which means total cost divided by the number of items produced. All right, so in our case, we're going to have C bar of X equals the total cost is 146 plus 4.4x divided by X. And we can simplify this by dividing each term of the numerator by X. So we're going to have 146 over X plus 4.4 because X and X will cancel for that term. In the next example, we're asked to find the marginal average cost function if the cost and revenue are given. Again, we don't need the revenue function for this problem. We're working with cost. So there are two steps to this problem. On the first step, we need to find the average cost. Okay, so the average cost function gives us the average cost for producing 1 unit at given level of production, X units. Okay, so we did this before. So C bar of X is C of X over X, and that is 190 plus 5.9x over X, and we simplify that to 190 over X plus 5.9. On the second step, we want to find the marginal cost, the marginal average cost. So the word marginal means first derivative. In our case, we're going to go the first derivative of the average cost. So that means C bar of X prime. So we're going to find the first derivative of 190 over X plus 5.9. Again, I'm going to use the power rule. So if I have 1 over X, I can write that as X to the -1. And using the derivative of a power, just we did before, we bring the exponent down, and then we reduce the exponent of X by 1. So -1 minus 1, and that will make it -1 times X to the -2, so -1 over X squared. And in our case, we're multiplying 1 over X by 190. So we'll go back to our derivative of the average cost function, and that will be the derivative of 190 over X plus the derivative of 5.9. So the derivative of the first term is 190, which is a constant, times the derivative of 1 over X, which we found to be -1 over X squared, plus the derivative of second term. This is constant, and derivative of constant is 0. So simplify this to -190 over X squared. Okay, in the next example, we're asked to find the profit given the cost and revenue. So profit let's call it P of X, is actually R of X minus C of X. So profit is the money that is left after covering the cost of making or producing X units. And R of X is revenue, which is the money that is made by selling these units. So in our case, P of X is going to be 2x minus 0.01 x squared minus 140 plus 3.4x. Make sure you put the revenue function and the cost function in parentheses. It's very important. So this first one is R of X, and the second one here is C of X. So P of X equals 2x, I'm simplifying now, 2x minus 0.01 x squared minus 140 minus 3.4x, and combining like terms, I will get negative 1.4x minus 0.01 x squared minus 140, which I can write in the standard form, negative 0.01 x squared minus 1.4x minus 140. Okay. In the next example, we are given the cost function, which is the total cost, and we're asked to find the exact cost of producing 31 processors. So we're making food processors here. So to find the exact cost, we're going to find the cost of producing 31 units. Then we subtract the cost of producing 30 units. So what is the cost of producing 31 units? We plug in 31 for X. So 1600 plus 70 times 31 minus 0.4 times 31 squared. I'm going to use a calculator to find this real quick. Maybe not as quick as I thought. So 1 minus 0.4 times 31. Okay, what calculator tells me, simplifying this, 3,385.6. C of 30 is 1600 plus 70 times 30 minus 0.4 times 30 squared. So I'm plugging in 30 for X. Okay, so 1600. All right, 33, 40. So the exact cost is going to be 3385.6 minus 3340 and that is 45.6. On B, we're asked to find the marginal cost to approximate the cost of producing the 31st food processor. So the marginal cost actually estimates the cost of producing the next unit. So in order to find the marginal cost of producing 31st unit, let's first find C prime of X. So the C prime of X is the derivative of the first term, which is 0, plus derivative of second term is 70, because 70 times X, minus 0.4 times 2 times X to the first. So 70 minus 0.4 times X. So to produce the 31st unit, we're finding C prime of 31. So I have 70 minus 0.4 times 30. Okay, so actually to produce the 31st unit, we're gonna find the marginal cost at 30. It's my bad here, my mistake. .8. I have another mistake here. You probably caught it by now, and you're saying no. 0.4 times 2 is 0.8. And I have 0.8 here. So let's do this again. .46. All right, so mistake I made was I used the marginal cost at level of 31, and that is incorrect. Producing the 31st unit, the cost of producing the 31st unit is the marginal cost when X is 30, because the marginal cost gives the cost of producing the next unit. Okay. So this problem has 3 parts. On the first part, we're asked to find the average cost per unit if 400 frames are produced, and then we're asked to find the marginal average cost at the level of 400, and then we're going to use the first 2 results to find the average cost per frame if 401 frames are produced. Okay, so what are we given here? The total cost function. So A, we did this problem before, the average cost per unit if 400 frames are produced. We denoted the average cost as C bar. So find C bar of X, which is 70,000 plus 300 times X over X, and simplify that to 70,000 over X plus 300. So we want the average cost per unit when X is 400. So C bar of 400 equals 70,000 over 400 plus 300. So let's find that out. 70,000 divided by 400 plus 300. Okay, it's telling me 317.5. Okay, so at this point, I'm going to ask you to do this as well. 70,000 divided by 400. Let me try this one more time so I don't make a mistake again. 70,000 divided by 400. Yep, I had it wrong. 475. Had a feeling it was wrong. Okay, in B, we're asked to find the marginal average cost. So first we're going to find the marginal average cost in terms of X. So as we did before, this is the first derivative function, which is negative 70,000 over X squared plus 0, because the derivative of the constant is 0. So negative 70,000 over X squared. In our case, we're going to find the marginal average cost at the level of 400. So we have X equals 400. So let's write this down. C prime of 400. We're plugging in 400 for X. Okay. $70,000. 0.44. I rounded to the nearest cent. I will not have room to answer C. So let me do some adjustments here. So C bar prime at 400 is negative 0.44. It's a negative here. Okay. C. In C, we're asked to use the results in A and B in order to estimate the average cost per frame if 401 frames are produced. So A gives us the average cost per unit when we produce 400. The marginal average cost when we produce 400 units tells us that the average cost when we produce 401 units is decreasing by 44 cents. So in that being said, the average cost of producing 401 units is actually $475, which is the average cost of producing 400 units, minus 0.44. So let's find that out. So the answer is 474.56. So again, because we found the marginal average cost, which gives us the average cost of producing the next number of units is decreasing by 44 cents when we are at level 400. So when we are at level 401, which is one more unit from 400, the average cost decreases by 44 cents. That's why we calculated the average cost per frame at the level of 401 to be 475 minus 0.44. All right, so I'm going to stop here with this example. Please let me know if you have any questions or if you catch any of my errors over here today. I hope you have a good day.